looking at some of those questions you have on 5. Let's start with 5.4 and see if there's anything there first. And just go ahead and unmute yourself and ask me if you have a question. Anybody? What about on 5.5? Let me see, by raise of hands, how many of you tried to do the homework for 5.4 and 5.5? Use the raise hand button if you did. Okay, it looks like quite a few of you have, and those of you that have, can't think of any questions that you had that came up when you were doing your homework.
So I couldn't find an example of it, but I remember there was something that came up, was whenever we divided by something, and then the exponents, we would divide it well.
Okay, yeah.
Just sort of seemed odd, because like everything else, the exponents were treated a little differently.
Right. Okay, let's maybe do one. Let's do a couple of examples here just to maybe help illustrate that and just to make sure everybody's on the same page on how to do these. So this is on 5.5. I'll do a couple here. 5.4 should have been a little bit easier because there wasn't you were dealing with perfect squares and stuff, but when you get to numbers that aren't perfect squares, and remember by perfect squares, I mean like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on, right? So these numbers 1, 4, 9, 16, 25 are perfect squares. And when you take the square root of each of those numbers, you just get a whole number answer, right? But when you take something like the square root of 60, x to the 5th, y to the 3rd, z to the 4th, right? 60 is not a perfect square. And so we're going to factor this down, and so one of the ways that I think is easiest for most students is to take the number and make a factor tree out of it. And so you're going to factor it down to all of their prime numbers. So that means, like, you can start anywhere. I'm going to start with 6 times 10 is 60, and then 6 can still break down to be 2 times 3, and 10 can break down to be 2 times 5. And now all of these numbers are prime numbers, right? So I'm going to stop there, and then I'm just going to rewrite it so that these are inside. I'm going to make this really big square root here so you can see all of my numbers and letters written out here inside of it. So I'm going to put them in order from smallest to biggest. So 2 times 2 times 3 times 5, the number part. And then I can see that there's 5 x's being multiplied together, so I'll have x times x times x times x times x, right? So 5 of them there. I have 3 y's, so 3y times y times y, and then I have 4 z's, so that are multiplied together, so z times z times z times z. All right, so if I'm just looking at this, and this is a square root, and you're going to be talking about different radicals in here. But if there's not a number shown as that index, then it is a 2. And that's going to tell you how many numbers you need that are the same in order for them to come out of the square root. So I'm going to just circle the pairs that I have in here. So I have a pair of 2's, so that means a 2 gets to come out. Right? I have a pair of x's, so that x gets to come out. Right? So I need 2 of the same in order for it to come out as that number or letter. I have some y's, a pair of y's, so y gets to come out, z gets to come out, and another z gets to come out. Right? And so these numbers that I have here, and letters that I have in purple, are all of the things that get to come out of the square root. So when I write that down, kind of simplify that a little bit more, I have 2, and then x times x is x squared, and then y, and then z times z is z squared. All right, so that's all of the stuff that gets to come out. And then all of the stuff that is left over, and I'll just keep it in black here to make sure you can see the difference. All right, so I still have 3 times 5 is left inside, so that's 15. And then I still have an x and a y left inside. Okay, and I think, so this would be your answer, but you're not going to always want to have to draw everything out like this. Like if we had x to the 33rd power, we're not going to want to have to write out like 33 x's and then find the pairs. So remember what you're really doing, and I want to make sure it's clear here to you. So when we have x to the 5th, right, that's really, we're trying to figure out how many groups of 2 do we have in 5? Well, 2, let me put this invisible 2 there again, right? So 2 will divide into 5 2 times with 1 left over. So that's how many times it divides in is what gets to come out, and then whatever the remainder is what's left over inside. All right, so if we try that for the y's also, 2 divides into 3 1 time with 1 left over. All right, and then 2 divides into 4 2 times with none left over. All right, so there's no z's left in there. So that's kind of the shortcut way to do it, so that you don't have to write out every number every time for that. Is that more clear, Colton, or was there something else on that you were curious about?
I couldn't find an example, but I seem to remember at one point there'd be the square root, and then you divide the numbers all by 2 or by something. And
right, and so that's what, yeah, so that's what I was saying. So since it's a square root, that's why we're dividing this. We're really doing x to the 5th, right, divided by 2. So 2 divides into 5 2 times with 1 left over. Do you think that's the part that it was talking about? Okay. Yeah, so you're just using this, that whatever this is called the index, right? And if it's a cubed root, it would be a 3 there. If it's a 4th root, it'll be a 4 there. But if it's a square root, it's invisible there. It doesn't show you a number, but you've got to know that that's like an invisible 2, and that's what you're dividing. You don't divide the whole number by that, right? You're just dividing the exponents by that, because if we think about it this way, right, we're thinking of how many groups of 2 are we making, right? I've got 2 groups with 1 left over if I'm looking at my x's. Right, I've got 1 group of y's with 1 left over. Right, with my z's, I've got 2 groups that get to come out with no remainder. Okay, let's try one more, at least with these typed, just to make sure, kind of, getting this idea here. And maybe this time we'll do it with a cubed root, right? So we can kind of see what happens if it's asking us to pull out things in groups of 3 instead, right? So if it has a 3 there, right, and it'll have to show you that. If it doesn't have anything, right, this is a square root. but any other root will show you, right? 3 or 4 or whatever, right? Cubed root, fourth root, and so on. All right, so one other thing that happened, and maybe I'll put this out in front here also. So you might have numbers and letters on the outside already. So let's say that we have like negative 3y, and this is connected to the cubed root by multiplication. It's not showing you that. So if you want to write a little multiplication dot there, so you remember, okay, these are connected by multiplication. So when I bring things out, I'm going to multiply it by what's already out there. Okay, so let's try something like this. What if I have, let's do, trying to think of a good one here. Maybe I'll do 48. Oops, do that as a black. Okay, so if I have 48 x to the 11th power, y to the 21st power, z to the 8th power. Okay, so let's try and do this one together. Again, we're going to start off, right, so the directions say to simplify, and that just means bring everything out of the radical that can possibly be brought out. Okay, that's what we're trying to do with this. So let's start off with our 48 again. So over here, I'm just going to do my little prime factorization for 48, right? And so maybe start with 4 times 12, right, is 48. 4 breaks down to be 2 times 2. Oops, what happened there? And then 12 breaks down to be 4 times 3. And then the 4 breaks down to be 2 times 2 again. All right, so again, make sure that when you do this, you don't forget any of those prime factors. All right, these are all of our prime factors on that. And then I'm going to write this down. So I've got the negative 3y is already out here. Right, but this time I'm doing the cubed root of, and let me write these in here. So I've got 2 times 2 times 2 times 2 times 3, right? And I'm not going to write all of these x's and y's out separately because there's just so many of them. I want to use that shortcut and make sure I'm seeing how to do that. Right? So again, right, since the index is 3, you got to pull things out in groups of 3. So I see I've got a group of 3 here, and so that comes out as a 2. Right? But then I've got to think about what I have here as far as my x's go, right? And maybe let me rewrite this a little bit differently. Maybe what I'll show is that this is, so a 2 is going to come out in front here. I'm going to write it kind of like that, showing that that 2 came out. So, so then what I have on the outside there is negative 6y, right? And I still have, I'm going to leave some space here because I'm going to be bringing things out, my x's, y's, and z's. So I'm going to leave some space there and then have my cubed root of whatever's left over, right? So I can see that my leftovers as far as my numbers go are going to be 2 times 3, which is 6. So 6 has to stay inside there. But now let's look at our exponents, right? So this is where we're doing the division. So how many times will 3 divide into 11? Three will go into 11 3 times, right? Because 3 times 3 is 9, with 2 left over. So I still have an x squared that's left inside here. Let me stop there and make sure. Is that, there are questions there? Is that making sense? And yes, this is recording. Okay. All right, so let's try the y's now. Right? So how many times will 3 divide into 21. So I want to try something on our chat because I feel like I'm talking to myself so much and so many people don't want to speak up. So we're going to try something new here. So everybody in your chat, I want you to tell me how many times 3 goes into 21, but don't hit enter quite yet. Okay, I'm going to have everybody have a chance to think about it, and then I'm going to tell everybody when to hit enter. Right? So go ahead and put your answer in to the chat box, but don't hit enter. How many times will 3 divide into 21? Right. Okay, so you should have your answer in your chat box. Let's try this. So I'm going to go 3, 2, 1, hit enter. All right, so most of you are saying 7 times, right? And it leaves no remainder on that, right? So that means that we're going to have 7 that get to come out. So y to the 7th comes out, right? Leaving no y's inside here because there's no remainder. All right, let's try this again on this last one for the z. So how many times will 3 divide into 8? And then how many left over? So like write, number, remainder, whatever, right? So when you write it in your box this time, tell me how many times it divides in and then what that remainder is. Okay, don't hit enter yet. Everybody get it into your box. So how many times will 3 divide into 8? And then how many are left over? Okay, let's go ahead and try it. So 3, 2, 1, hit enter. Okay, awesome. Most of you are saying 2 remainder 2. All right, so remember, that means that z to the 2nd gets to come out because that's this 2, how many times it goes in. And then remainder 2 is how many are still left inside. So z to the 2nd is still left inside. All right, so this thing, it's almost all simplified, but do you see that we still have y's in 2 different places? So we've got to do this y times y to the 7th. All right, so get those guys together to have our final answer. So we'll have -6, and usually we put our letters in order, in alphabetical order. So I'm going to put my x's first. So -6, x to the 3rd, y to the what? Somebody just type it in the chat. Y to the what power? Okay, Megan says 8, right? Because we're doing 1 plus 7. When you're connected by multiply, you add those exponents. So y to the 8th, and then z to the 2nd. And then make sure that you're writing down, don't forget that index there, right? That cubed root, 6x squared, z to the 2nd. And on your homework, make sure, so when you click on your answer box, right, when you click on there, I can't remember which side it's on, but there's this little like arrow, like a yellow arrow or something, and if you click on that, it gives you a whole bunch of different options, and it'll give you like a square root. It'll also give you something where you can put an index in to make it a cubed root. Right, so make sure that you're looking for some of these little tools in there. It'll make it easier for you to enter your answers in. Did anybody have that? Like trouble with any of that? Okay, so just want to make sure that, if you have any question about how to put those things in, like reach out to me. Don't just sit there and get frustrated and keep missing it because you might have the answer correct when you work it out here, right, over this way, but then when you go and try and put that into the homework program, it might be just a little bit different in the way that you need to set that up. So just play around with those little tools a little bit, but make sure if it's a cubed root, right, that you're making it a cubed root. not just the square root. Does anybody have any like hints or, helps or anything like that that you found when you were doing your homework that you think might happen to, or might help people you came across? All right, so many talkative people today. Wow, okay. All right, somebody was asking, though, about doing an example with a negative inside the radical. And so remember, if it's a square root, so let me kind of go down here a little bit. If you're asked about finding the square root of a negative number, so let me give you a little example here. We have the square root of negative 64. All right, this is asking us to figure out what number squared gives me negative 64. This is what it's asking. So you're trying to think of what number times itself could give you a negative number. And there is nothing, right? Because if I try and think like negative 8 is what a lot of times people put for an answer on this. But remember, negative 8 times negative 8 is a positive 64, not a negative 64. So when we look at this, and you can't have two different numbers. You can't have a positive 8 and a negative 8 because we're trying to square that number, right? So there is nothing that works for this. So when it has a square root or a fourth root or any kind of even root, then we're just going to put DNE, or that just means that there's no real solution. So meaning you can find a solution, but not in the real number system. So it doesn't exist in the real number solution. Right? And so, when you talk about this, another math class and stuff, you'll talk about like the imaginary number system, and that's what we have to do when we have negatives inside square roots. But if we have a negative inside a cubed root, right? So if I did the cubed root of negative 64, okay, this time it's saying what number cubed gives me negative 64. So what number times what number times what number, right? It has to be the same three numbers. So what times what times what gives me negative 64. Okay, and so this one we can find an answer to. This one isn't a DNE, and a lot of times people will put that because they get a little bit confused why, when you have a square root, there's no real solution, but here there is. But think about it. If we do negative 4, put negative 4 in here, right? So if I take negative 4 times negative 4 times negative 4, right? Well, negative 4 times negative 4 is positive 16. And then if I times that by another negative 4, that does give me negative 64, right? So I can end up with a negative number when it is a cubed root or a fifth root, anything that's like an odd root. I can find the answer for those. So the answer to this would just be negative 4. Right? This is kind of how I go about figuring it out, but I want to make sure it's clear that negative 4 is my answer. We're saying what number cubed will give me negative 4. Right? And I want you to think of your calculators too. You will be able to use your calculators on this. But your calculators, they'll tell you, like, they'll give you some kind of weird error or something like that. If you try to put the square root of negative 64 in, sometimes it'll say domain error, or just error, or it just depends on your calculator, but it'll give you some kind of an error saying that's not possible because it doesn't exist. But when you put the cubed root of negative 64 in, you will get negative 4. Okay, so think of your calculator as you know, as a tool there to help you, but you do need to show your work and stuff on these too. So it can be there to kind of help check it, but I want to make sure you're understanding how we're getting to those answers, not just, oh, I put it in my calculator and magically this number appears, right? There's a reason why those numbers come out, and I want you to understand those, okay? All right. Any other, since we've been talking about this, let's see, Emery, did you have a question? Your hand's up, Emery. Okay, that's fine. Yeah, you can just put your hand down if you didn't mean to have it up. And just click on it again, and it should go down. What about Megan? Did I answer your question? Or is there something more you'd like to ask?
No, you answered it.
Does that make sense? Okay. All right, I just want to make sure it's making sense to you guys, and when I can't hear from you or whatever, I just don't know. It's hard for me. I can't see your faces on most of the screens, so it's just hard for me to know. If you do have your video, I'd really like you to have your video up, because it just helps me to be able to see people's faces and understand, like, okay, is that making sense? Are they still working? Are they, you know, are they confused? It would just be really helpful for me. All right, well, that at least kind of is a little bit of an overview. And like I said, if you're still not sure on 5.4 and 5.5, watch those videos. Like, come to my, you know, my online office hours. I've got office hours tomorrow evening, right, from 5 to 7 p.m. So if you can come at that time, and I just meet in my office, right? Not in this WebEx, but in my actual office. On the home page of our Canvas, the bottom of it, it says Becky's Virtual Office, and it's a little link there, right, with my office hours. So click on that, and then it will take you to where I'll be doing my office hours, because it's going to be more than just our class that is there, because I have some other 980 classes that would join us as well on there, okay? But oftentimes I'm just sitting there by myself and nobody else is there. So if you have questions and can come at that time, please come. It'll be so much better. I can't, you know, it's hard to answer all the questions in our class time. Just this format is just different and stuff. So that just gives you one more place where you can get help from me, okay? All right, let's move on to 5.6 then, and let's talk about something called the Pythagorean Theorem. And we're going to need to understand radicals, specifically square roots, to be able to use the Pythagorean Theorem. So that's why we kind of talked about it there, okay? And some of you may have seen the Pythagorean Theorem before in other classes. Pythagorean Theorem. Right, and the Pythagorean Theorem says a squared plus b squared equals c squared. And so with this a, b, and c, you've got to know, well, where are those numbers coming from, right? So the Pythagorean Theorem can only be used on right triangles. And I know it's a right triangle if one of the angles has a 90-degree angle to it, right? And then the two legs, and they're called legs of, so this side and this side, right, that are coming off of that 90-degree angle are called the legs. That's the leg of the right triangle. And then the other side, so the one that's just opposite our 90-degree angle, and over here, is called the hypotenuse. Right? And the hypotenuse is always the longest side of the right triangle, and it's always opposite of that 90-degree angle. Okay? And so on our Pythagorean theorem, the hypotenuse is always c. And then it doesn't matter which one of the legs you call A and which one you call B, but you just need to know that these two legs, right, are the the A and the B are going to be the legs, and then the C is always the hypotenuse. Okay, so I'll try and draw it that way. Hopefully that'll make more sense there. Because remember, with addition, it doesn't matter which order you do things in. That's why it doesn't matter which leg you call leg A and which one you call leg B. Okay. All right, so let's look at some of the questions that you might have come up for these Pythagorean theorems. Right? So if it says something like this, so let's find the length of the missing side. Okay, and so on this one, so there might be some where they give you some pictures of what's going on. All right, so I give you a little right triangle here, and then it says this one's 7 feet, and this one's 24 feet. And so you're trying to find the length of the hypotenuse on this one, right? And then again, we can tell it's the hypotenuse because it's the longest side and it's the one across from our 90-degree angle. All right, so then we need to set it up so we have, one of the legs squared plus the other leg squared equals the hypotenuse squared. So let's do that. So I'll have 7 squared plus 24 squared equals c squared. All right, and now according to order of operations, to kind of like simplify this, all right, I've got to square these numbers first, and then I'll add them together. All right, so 7 squared, 7 times 7 is 49. And then 24 squared, right, you can put it into your calculator as 24 times 24, or you can put it in, there's a squared button on your calculator. You can put 24 squared, and that's 576. Right, and that is what we're trying to find. We want to know what c is, not c squared. So we're going to try and solve this for c. So it's really important to make sure you put that c squared. So we've got the 49 plus 576 equals c squared. So let's add these guys together here, which is going to give us 625 equals c squared. Right? And then something that you need to remember is that squaring something and square rooting undo each other, right? So whenever there's a way to do something in math, there's always a way to undo it. So I'm going to just put this down. The way to undo, right, something squared take the square root of both sides, okay, of this equation. So look here, so I'm trying to get this c by itself, and right now it's squared. So if I square root this side, well, this square root and this square are opposite operations, so they just undo each other, and that just leaves me with c on this side. And that's what I want to know. I want to know, right, how long that side is, right? And this one, I guess I put an x there, but maybe I should, put that down as a c, just to make sure you kind of, they don't always use the a, b, and c's. They'll use some other letters. Right? And then on the other side, so then on your calculator, you'll just figure out what's the square root of 625, right? And 625 square rooted is 25. So that means our answer is 25 feet. Right? So our hypotenuse, right, this side of my triangle is going to be 25 feet long. What questions can I answer in that first example? How many of you, by raise of hands, remember seeing the Pythagorean theorem before in other math classes? Okay. pretty good amount of you. Some of you might remember hearing the Pythagorean theorem, but maybe you're like, I don't really remember how to use it, but I know I did it before in another class. Okay, let's try another one. So example 2. Oops. So on this next one, so sometimes it won't give you a picture. It might just, give you, well, I'll do a picture on this one again. So I'll just say find length of missing side. All right, so this time if I have something that looks like this, right, and I know that this is 5 meters, and this one is 13 meters is this one. All right, then we're trying to find the length of that other side. Okay. So will somebody tell me how you would set this up using the Pythagorean theorem? Like, put the numbers in where you think they need to go and tell me what that would say. Somebody have that?
Would it be a squared plus 5 squared equals 13 squared?
It is. Does everybody see why that is? And you could have said 5 squared plus b squared, right? And it doesn't matter which one you're calling a or b. So this is perfectly great, right? We've got one of the legs. We know the length of one of the legs, and we also know the hypotenuse, right? So make sure you're not putting the 5 and 13 on the same side of the equal sign this time, right? They got to be on opposite sides because you got to think of which are legs, which are hypotenuse. Okay, so then when we do this, let's simplify this up. So we've got a squared plus 25 equals 13 squared is 169. All right, and then we're trying to get our a by itself. So let's first start by subtracting that 25 over. So we'll have a squared equals 144. And then again, to undo squaring something, we need a square root both sides. All right, so square root of a squared, right, that square root and the squared are opposite operations. It's like they're canceling each other out. And then we're left with a equals 12, right, and 12 meters specifically on this, right, because we're talking about the length of a side. So we need to make sure that we put that in there. All right, what about questions on that one? Is this feeling okay to you? The only thing really different on this is the setup of it. So I just want to make sure everybody's clear on why, you understand why we set it up this way, right, with the 5 and the 13 on opposite sides of the equal sign, where on this one, right, we put the numbers on the same side of the equal sign. All right. Well, let's look at one with like a story problem, because you will have some story problems on these problems with the, because then oftentimes I would say, I don't know, probably at least 80% of the time on the final exam, right, you'll see one of these application problems to, using the Pythagorean theorem. So it's really good to make sure you understand these well, right? So let's look at this third example. So this time it says, given a rectangular frame that is 12 inches by 10 inches, how long is the diagonal from one corner to the other. All right, so on this one, it doesn't give us a picture, so we need to draw our own little picture. We're thinking, okay, we've got a rectangular frame. So let's draw a cute little rectangle here. All right, and all we know is that the frame is 12 inches by 10 inches. All right, so I'm going to say this one's the 12 inches, and this one is the 10 inches. Right? And then we want to know how long the diagonal is, right? So it doesn't, so we've got to think about, all right, I've got this imaginary diagonal line here, right? And then you can see, oh yeah, that's making a right triangle now, right? Because rectangles always meet at 90-degree angles, so we know this is going to make a right triangle here. Right? So again, if we're using the Pythagorean theorem on this one, we're trying to find the hypotenuse. That's what's missing here. Right? So we'll set it up as 10 squared plus 12 squared equals c squared. And then on this one, you're not going to get a whole number answer to it. Right? So I want you guys to take a minute and solve this for c. And when you get down to the part where it is the square root of it, and so I want you to write the exact answer, which means it's going to be in like square root form still, and it also wants you to write a decimal answer. So decimal rounded to 2 places. To 2 places, right? So the hundredths place is where we're going to be rounding to on this. So it's going to be blank. Right. Okay, so let me give you just a minute. Solve this, figure out what C is. I want 2 different answers for this. Okay, when you get your decimal answer, rounded to the hundredths place, I want you to type it into the chat, but don't hit enter yet. Okay, let me give everybody a chance to try and think through it. So enter your answer in there, but don't hit enter yet. Okay, so if we kept it in exact form, we'd want to see if we could, simplify that anymore, like we talked about, if it asks for it to be in exact form, meaning if we took 244, we were thinking, okay, well, I know, 4 divides into it. Let's see, it would divide in 61 times. And so, and then 4 breaks down to be 2 times 2. So on some of your calculators, it'll even, change that. It won't leave it as square root of 244. It might have it as 2 square root of 61, right? Because we have a pair of 2's that gets to come out, and then the 61 stays inside, right? So either of those two are great for the exact answer, okay? But they'll want you to change it to be like 2 square roots of 61 on the homework for you to get it right if it asks. So if it asks for the exact answer, then this would be the better one to put in here. Okay, questions on that exact answer? Okay, and then if you did, so on some of your calculators, it just leaves it in the square root form. But you'll notice usually on the calculators that do that, down by the enter button, like right above it, there's like 2 little arrows that are kind of pointing away from each other like this. It's usually like right above, right next to that enter button. So if you see something like that, right, button that says something like this, and you click on it, then that's going to change it to the decimal approximation. Right, and then you can come up with that and round to the nearest hundredth. Okay, so everybody right now, make sure you have an answer put in your chat box for your decimal, right, what the decimal is on that. Okay, and then I want to see you, so let's do 3, 2, 1, hit enter. All right, I've seen a lot of you coming up with the same thing, right? And this one, there was actually 2 places in front of it, but you understood what I meant. So 15.62, right? So 15.62 is your approximate answer. So when it asks on the homework for an exact answer, right, it's wanting it in square root form, but when it says it wants it as an approximate, it'll tell you where to round it to, how many place values to round it to, and use your decimal. Okay. All right, questions on that one? Understanding exact and approximate answers, when to put what. And Pythagorean Theorem is really cool. You can actually, do a lot of really cool things with it. So it's kind of a fun little formula. That is a formula that you need to make sure that you have memorized for the final. I mean, speaking of the final exam, we haven't figured out exactly what we're going to be doing for it yet, but I will let you know as soon as we figure that out. It might be that they're going to do like open notes. It might not be open book, but it might be an open notes one, so make sure you're taking good notes because that could be a possibility on this one. And it probably is going to be something that is on Canvas. It's going to look like a Canvas quiz, if you've seen those. It's going to be kind of like that, probably, but we're not totally figured that out yet. So be patient. We're still trying to figure it out, and I will let you know as soon as I know when the math department makes a final decision on that. Okay, because I know some of you really want to know, and I tell you what, I really want to know too, because it would help a lot. So, but hopefully we'll know soon. All right, let's do one more example. I'm going to write out the example, kind of draw a picture of what it's showing, and then I want you to take it from there and see what you can do as far as solving it. And again, you're going to be doing the exact answer and the approximate answer, okay? But this one says, so we're just giving words this time, a little story problem. A 6-foot ladder is placed against the wall. Oh, sorry, that kind of all looks like one word. If the base of the ladder is 3 feet from the wall, how high up the wall will the ladder reach? Okay, so again, this is all that's given to you, and so you kind of have to make some sense of what this is saying, right? Where that 6 is, where the 3 is, how that's being used. So let's just draw a kind of a picture of this, right? So let's say that this is my wall, and I am not a great artist, so you'll just have to kind of bear with me here. All right, there's the wall, and then the ladder, right, is somewhere going up the wall, right? And at some point it's hitting the wall up here, right? And it's telling us that we know the base of the ladder, right? So it's the bottom of the ladder here, is going to be 3 feet from the wall. So we know this is 3 feet. And we know that the ladder, right, is 6 feet. So that's going to be here. It's kind of hard because we got this 3D thing, but just look at the triangle that's kind of inside here, right? So that part's 6 feet. All right, and so we're trying to figure out how far up the wall it's going to reach. Okay, now do you think that that answer would be more or less than 6 feet? Somebody just chime in, just unmute yourself and tell me what you're thinking. Do you think the length that we're trying to find here is going to be smaller or bigger than 6 feet? What'd you say?
Less than?
Okay, why less than?
The ladder in this case was the biggest.
Yeah, the ladder is our hypotenuse, and our hypotenuse has to be the longest side, right? That's just by definition, that's what the hypotenuse is. So this is not going to reach 6 feet up the wall, right? It's going to be less than 6 feet up the wall. And you think about that, that makes sense if you're thinking about it in real life. Okay, so go ahead and use the Pythagorean Theorem to solve it using these things. Remember, I want an exact answer, and I want it approximated this time to 1 decimal place. Okay, so 2 different answers. Okay, raise your hand when you get to an answer. Just click on your hand raise button so I can see where everybody's at. Make sure you have both answers, the exact and the decimal approximation. I rounded to 1 decimal place this time. Paige, would you mind telling us the way you set up your Pythagorean theorem? What does your equation say starting off?
So I wrote my equation as 3 squared plus b squared equals 6 squared.
Okay, awesome, right? Your hypotenuse has to be on one side and your legs are on the other side, but we're trying to find one of the legs, right? So that's got to be like this, right? You could have set it up as a squared plus 3 squared equals 6 squared also. So if you set it up that way, that's perfectly fine. All right, so then if we try and simplify this, right, 3 squared is 9, so 9 plus b squared equals 6 squared is 36, right, and then I'll subtract my 9 over, right, so I get b squared equals what?
27.
Yeah, 27. Okay, and then, what do we do from here?
You do the square root of b squared and then the square root of 27.
Awesome. Yeah, we're trying to undo that square, so we'll square root both sides. Right? And then there's, whoops, there's nothing there. Sorry, I didn't mean to do that last little thing. So we've got b equals, right? And then, so for our exact answer, what is the square root of 27? Somebody get that?
Is it 3 times the square root of 3?
It is. Yep, 3 times the square root of 3, right? Because if we take 27, we break it down, that's 3 times 9. 9 breaks down to 3 times 3. So a pair of them get to come out. And then that other 3 is still left inside, right? So our exact answer, right, is 3 square roots of 3. But think about this, like, I mean, if, you know, you were to go, you know, to Home Depot or something, and you were like, I need 3 square root of 3, you know, foot of this board or something like that. You're going to be like, what? What are you talking about, right? That just looks so weird. And so that's really, you know, why we deal with the decimal approximations, is because it helps us make more sense of what we're talking about, especially in story problems. It's a lot better, right? And so then, and so somebody want to share with us, what did you get for your decimal approximation on this? Just put that little... Okay, I'm here seeing a lot of people in the chat and saying 5.2, right? And again, it's 5.2 feet. Make sure you don't forget your label on that, right? And that makes sense because if we have our ladder is 6 feet tall, we know it's not going to reach up to 6 feet on there. So 5.2 seems like a reasonably good answer on that. Okay, but those are our two different answers. So if it asks on the homework for exact, keep it in the radical form. If it wants the approximate, it'll tell you where to round to, what decimal place to round to. Okay. What questions can I answer on that one? Is everybody able to set it up? Okay. And remember that it's not exact unless it's in that radical form, right? So even though, like, when you put it out on your calculator, like you'll see like 5.1961, blah, 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 right? This is not exact because this keeps going and going and going and going on forever, right? And so it's kind of like the number pi, where it never repeats and it never ends. And so that's why this is the exact answer, because we can write it down in a way where we don't have, these never-ending decimals. But this, right, the approximate way is just easier for us if we're like thinking through things, like if we're trying to do like a project or something like that. We need to know how much wood we have or whatever it is that we're dealing with there. Okay, let's take a little 5-minute break. All right, get up, stretch your legs, just stretch your brain. I don't know, relax your brain for a few minutes. And then we'll come back and we will work on the 5.7 also today. Okay? And feel free to reach out to me if you have some individual questions too you want to ask about. Don't be afraid to speak up, please. Okay, let's get back to it. All right, so we are going to be in 5.7 now, and in 5.7 we're going to be talking about polynomials. So it's a little bit of a shift from what we were just talking about, but I want to talk about this word polynomial first of all. All right, so poly means many, and nomial means terms. So a polynomial is, something in math that we say has many terms. Well, it's important to understand, what do I mean by a term, right, in math? And so, let me give you an example of a polynomial, and then we'll talk a little bit about this polynomial. So let's say I have something like 3x to the fourth minus 5x to the third plus 7x squared plus 8x and then minus 4, something like that. So this, I'm going to use these different colors to try and help illustrate this. So terms are connected by add and subtract signs. Right? So that means that this polynomial has 5 terms. Right? All these different parts right here, 5 different terms. And so with this, you'll notice that there is some exponents on our variables here, and those tell us about what we call the degree of the polynomial. So if we look for the highest degree, or the highest exponent, that's going to be the degree of it. Okay, so I'm going to put that here. So this is the degree, and we can tell what it is because it's the highest exponent. And when you have polynomials that have like y's and z's and stuff in them, we're not getting into those in this class, and so you won't have to worry about finding the degree of a polynomial that's like that, but you will be doing that in some other classes. So just make sure that you know that this is just kind of only if we're dealing with maybe one variable in this polynomial. Okay, so let's see, so we've got the degrees. We also want to talk about this first term. So this whole thing right here, right, is our leading term, because it has the highest exponent to it. So even if this was written in a different order, right, this would still be, we'd need to write it what's called descending order, and we'll do that as part of our examples, where we have the highest exponent, then the next highest, then the next highest, right? And some of these terms, like there might not be an x squared term sometimes in there. And so we would just keep looking for, okay, what's the next highest, what's the next highest, what's the next highest, okay? So this is the leading term. Now the numbers out in front of each of these, right? So I'm circling -5 because that negative is part of that. All right, so these are called coefficients, right? And I think I've used that word before in this class, where it just means the number in front of the letters, right? Are the coefficients. Okay, so that's these things here. All right, and then this last term, it also has, right, the one that doesn't have a letter with it is called the constant term, because it's always going to stay, this term is always going to be -4 no matter what, because there's no variable there to multiply it by it. So like this, 8x, that term is not going to stay as 8 always, just depending on what our x is going to change that term, but this is always going to stay constant. That will be our -4. There is our constant term. Okay, so these are just different parts of this, let's see, I'm going to go, let's see, I want to make sure you see that this 5.196 kind of got in the way there. I'm just going to scribble it out right here so you don't think that's part of that was the last question that we did here. All right, so these are just the different parts of our polynomial. Now, there's some polynomials have special names to them. And so if we have something like this, it says like just 3x squared. It has one term, and so we call it that a monomial. Right? Because mono means one, so one term. Right? If we have something like x squared minus 3, this has two terms, and so we call those binomials. Oops. Easy for me to spell. Oh my goodness. Right? And if something looks like this, like with 3 terms, then we call that a trinomial. So these are the only ones that have special names to polynomials. Anything larger than 3 terms is just called a polynomial. Right? So any polynomial with more, right, more than 3 terms, so 4 and on up, is just called a polynomial. All right, but I will be using these words, this monomial, binomial, trinomial, so I want you to know what I'm talking about, right? It's talking about specific types of polynomials that you'll be dealing with. Okay. Also, I wanted to talk about, so let me do some examples over here. So if I asked you, what is the degree of the terms? So sometimes it'll ask what's the degree of the terms, and sometimes it'll ask what's the degree of the polynomial. So like this 4 up here on the example I gave you above was the degree of that polynomial because it's the highest exponent, right? But if I gave you something like this, so 3x squared plus 5x minus 4, right, as a polynomial, well, the degree of this term is degree 2. This one, even though there's not a little exponent written on that, right, that's degree 1. And then this one is kind of like, and let me put this in a different color. We really could say that this is like x to the 0 power. Remember when we talked about these properties of exponents and we said anything raised to the 0 power is just 1? And so that's why we don't show the degree of this. We don't put that x to the 0 power there because it is just a 1. But when we're talking about the degree of this one, the degree of that term, right, is 0. Because that's what my exponent is there, right? So there's kind of like invisible exponents here. We've got that invisible 1 that we have to put in there, and then this one is really degree 0, right? But the degree of the whole polynomial, right, the whole polynomial is that highest exponent, so it is 2. Because that's my highest exponent. So just make sure you notice on the homework, right, it might say what is the degree of each of the different terms, and then what is the degree of the polynomial, the whole thing, and that's when you're looking for the highest out of all of the terms. Okay. All right, questions on just the different parts of the polynomial? Anything that I can clarify more for you there? Okay, well, let's talk now about adding and subtracting polynomials together. All right, so let me do a little example here. So I might ask you to add the polynomials, and I give you x to the third plus 4x squared minus 5x plus 2. All right, so this whole polynomial, all right, I want you to add to, let's do 7x squared minus 4. All right, so notice that this polynomial, the first one, has 4 terms in it, where the second one only has 2 terms in it. And you can only add polynomials that have like terms. So what you're really doing is you're combining the like terms. And by like terms, right, that's like if I had 3x squared and 4x squared, right? They have the same variable with the same exponent on it. That's what makes it a like term. If I had 5x and 5x squared, I can't add those together because they're not like terms. I've got an x and I've got an x squared. All right, so these guys are like terms, right, where these bottom ones here are not like terms. All right, so they have to have the same variable, and then they have to have the same exponent on that variable. So they have to be to the same degree. All right, so the only things that I can add together here, and I'm just going to put it one underneath each other. So I have, you know, a 7x squared, so I'm going to add that to the other x squared. And I've got a minus 4, so I'm going to combine that together with our other number there. Right, and then I'm just going to add these guys together. Some of them I don't have anything to add with it, right? So it just stays the same. It's like I'm adding 0 to it. This one, 4 plus 7, gives me 11, and keep it as the x squared, right, because they had to be the same. Then minus 5x, and then 2 minus 4 gives me negative 2. So this is what I get when I add those two polynomials together. Right, so I can only combine those like terms together. Another example that you might have might be something like this, where it just says combine like terms. And it gives you something like this. So 7x squared minus 4x plus 3 minus 2x squared minus 5x minus 1. All right, so it just gives you a long line of terms, and it just wants to make sure that you know which ones you can add together. Right? And again, those have to be our like terms. So if I'm looking at this, I can say, okay, my 7x squared and my negative 2x squared can be combined together. So 7 minus 2 gives me 5. And then again, I have to keep that x squared part to it. All right? Then I can see I have some x's that I can add together. So negative 4x plus a negative 5x gives me a negative 9x. Right? And then if I have the whole number parts, right, I can see, okay, I've got 3 minus 1 gives me that positive 2. So that would be my answer on this. Right, simplifying them by just combining those like terms together. Right? But the next thing we're going to talk about is multiplying. So when we're adding or subtracting polynomials, they have to be like terms. When we're multiplying polynomials, we don't need like terms. Okay, so that's the biggest difference there. You might want to write that down somewhere in your notes, right? So when you're adding or subtracting polynomials, right, you have to have like terms. When you're multiplying them, you do not need like terms. So let me show you what I mean by this. So if I have, examples on. Okay, so example 3. If I ask you to multiply, and I give you a monomial, like 4x cubed, and then in parentheses next to it, I say 5x squared minus 2x plus 5. All right, so I'm taking a monomial and I'm multiplying it by a trinomial. Well, this is where we have to use the distributive property because it's telling us we're going to take this 4x cubed and I'm going to multiply it by everybody that is inside that parenthesis. Right? So this is the distributive property that we use here. So with the first part, right, we've got, so this 4x cubed times 5x squared, that's going to be, it's a different color here a little bit. So we're going to multiply the 4 and the 5 together, so that gives me 20. And then x squared times x to the second, remember when we did this with properties of exponents, right? That's just saying x times x times x times x times x, right? So there's 5 of them all together. So remember when you're multiplying those x's, you're adding the exponents. So x to the 5th power, right? On that first part, we use a different color now to show this next one. So 4x cubed times negative 2x now. So 4 times negative 2 gives me negative 8. X cubed times x, remember that has an invisible 1 power there. So 3 plus 1 gives me 4. So x to the 4th power. All right, and then let's do this last one. 4x cubed times 5, right, is going to give me 4 times 5 is 20. So plus 20, and then x to the 3rd. And then I'd want to look and see if there's any like terms that I can combine together, but all of my exponents are different from each other, so there's no like terms, and that would be my answer. All right, let me take some questions. I'm not sure if there's any questions that you have so far about adding and subtracting these polynomials or multiplying them. What questions can I answer here so far? Please speak up. If you have a question, somebody else in the class has the same question. It would really be helping a lot of people out if you're asking your questions. Okay, well, I'm going to move on to the next one then, if you don't feel like you have any questions there. Okay, remember tonight I've got office hours, right, from 5 to 7 p.m., and that's in my online, like my WebEx online office. And you can click on the link that's on the home page to get to that online office, to get into my office hours. All right, but let's look at something else. So this one was a monomial multiplied by a trinomial where you're just distributing that through. This next one looks a little bit different, right? So for example 4, we're going to have a binomial multiplied by another binomial. So if I have like x plus 7 times x minus 2. Right? And so some of you have heard used the acronym FOIL to help you remember how to times these binomials together. Right? So the F stands for first, which means you take the first term of each of the binomials and multiply them together. So x times x gives me x squared. Right? Then the O stands for outside, that means you're going to take the outside terms of each of those binomials and multiply them by each other. And so that x times negative 2 gives me a negative 2x. The I stands for inside. So now I'm going to take my inside terms and multiply those together. So 7 times x gives me 7x. And then the L stands for last, and that means multiply the last term of each of the binomials together. So 7 times negative 2, actually let me write it maybe the other way. It's a little bit easier to see. All right, so 7 times negative 2 gives me negative 14. All right, so this just kind of helps us figure out, okay, make sure that you're multiplying by it. But notice, we're really just doing the distributive property. We're taking the x, timesing it by the first term in that second parenthesis, taking this x, timesing it by the second term in the parenthesis. Right? Then we're taking the 7 and distributing it to both of those. Right? So it's kind of like we're doing that distributive property twice. Some teachers don't like students using this word FOIL, but I say whatever helps you is what I want you to use, right? Just make sure that you're multiplying everything by each other that you need to. Also in this one, you should notice that there's some like terms here in the middle. I've got a negative 2x and a 7x that I need to combine together. So I've got my x squared. Then when I combine the two middle terms, I get plus 5x and then minus 14. And so that would be my answer. When I multiply these two binomials together, I get x squared plus 5x minus 14. Okay, let's try it on another one. So you can try this one out. All right, so how about if I have, let's do 5x minus 6 in one parenthesis. And then let's do 4x minus 1 in the other parenthesis. Okay, so I want you to try and use this FOIL idea, right? Multiply those binomials together, get your like terms together, and then see what you come up with for that final answer. Okay, when you're done with example 5, look on the screen. If you came up with that answer, you click the raise hand button so I can see where people are at in understanding. And if you didn't get that, will you ask me a question if you're not sure somewhere I can help you with? Anybody? Okay, put your hands down then. Just click on it again to lower your hands. Okay, So remember, you're just doing the first, outside, inside, last, right, on these when you have a binomial times another binomial. All right, let's try another one here. All right, so usually it'll just say like the directions are multiply and simplify on something like that. Okay, but what if they give you something like this? All right, so what if we have 3x minus 7y all squared? Right. Well, remember that this squared is saying take what's in parentheses and times it by itself. So you really need to write it out again. So we're doing 3x minus 7 and then parentheses 3x minus 7, or sorry, 7y I meant, right, on both of those. So write those out. Okay, and then I want you to do the FOIL again on this. Do the first, outside, inside, and last. On this one, all right, remember you got to do the FOIL on this. Some students, I'm just going to tell you this common mistake because I don't want you to make it. I want to warn you about it. But some people try and just, you know, raise the 3x to the second power and then raise the negative 7y to the second power. Well, that would give you the first and the last term, but you miss the problem because you have all of this middle stuff that you never took care of. So that's why it's important that you write this out twice and then do the FOIL method. Now notice we haven't had one like this before where we have two variables, but notice our middle terms, right, are negative 21xy and negative 21xy. So those are common, right, because we have an x and a y and an x and a y. So those are like terms. And also on this last one that I have in orange, right, you got to make sure that that one is squared also because you're doing the negative 7y times negative 7y. And remember that these like have these little invisible, right, exponents on them. So if you want to put those in to help you remember, you're doing y times y. So adding those exponents together gives you the y squared. Okay. What about questions on that one? Okay, we're going to do one more. So I want to show you something kind of cool that happens here. So notice that these are almost the same. We have, you know, x plus 5, and then this one it just is connected by subtract instead of plus, so x minus 5. When we multiply those type of binomials together, look at what happens. So we do our first term, so we x times x is x squared, right? Then we do our outside terms, x times negative 5 is negative 5x. Right, then we do our inside terms, which gives me a positive 5x. And then I do my last term, which gives me a negative 25. So now, when I am combining my middle terms together, you see that these guys are really just canceling each other out. So we've got a negative 5x plus a 5x, which is just 0. Right? So these guys really end up going away. And so we're really just left with that first and last term there. So x squared minus 25 would be your answer on that. Okay, and that always happens when we have a binomial that's almost exactly the same as the other one. It's just one's connected by add and the other one's connected by subtract. Those middle terms just cancel each other out. So that's why we're ending up with a binomial there instead of a trinomial. Any answer any questions on that one?
the constant term have to be the same when it cancels out?
What do you mean by the same?
So, on this example, it's 5 and negative 5. Would it have to be like the same constant term, just positive and negative on both sides?
Yes. Yep.
Okay.
That's right. Yep. Okay, so we are going to do, I am going to, let's see if I can stop sharing. No, actually, maybe I'll just pull this over here. Let me. Okay, so I want you guys to write down some of these questions because this is going to be a little quiz, but I want to give you a little bit of time right now to work on this before class ends and just see like what questions you have on it. This is going to be on your, I'm trying to remember if I put it on there already. I don't think I did, but I'm going to be putting this quiz on Canvas. So if you don't finish it right now in class, that's fine. You're going to get in later and work on this quiz. And I want to see all of your work on it because this will help me give you some feedback about how you're doing on it. And remember, I mean, I want you guys to reach out to each other and talk to each other. I know this is just weird and, you know, I wish we could get into groups and classes and stuff like that like we used to, but we're going to have to just find other ways around it. So you guys can talk to each other in the discussion board. And I would highly suggest you doing that. You know, if you like are stuck on one of these, you know, going, oh, you know, with this negative exponent, you know, here, I'm not quite sure, what would you do on this? Would you distribute it through? How does that affect that negative 6 out there? Just bring up, you know, some questions that you have on there because a lot of you are going to have similar questions. And then there's going to be other people there that can answer those questions, but might have questions on others' parts. So this you can just do in the discussion board. And so I want you to do that. And if there's not a link already on the front page, on the home page, I'll put that link on there for you. Make a note of these things. But go ahead and start. I want you to start on these 4 questions here and see how you can do. So write those down. You can just write these down on lined paper and turn it into me that way on the lined paper. It doesn't have to be on this quiz sheet, so you don't have to print it out or anything. And this will be called Module 5 Group Quiz, if you want to put that at the top. So when you need to go back in and work on the rest of these, you'll know where to find that on. All right, so this is the group quiz, not the regular quiz, just the group quiz.
I have a quick question.
Yeah.
So it says negative 5x to the 5th y, and then is that a plus or multiply?
Oh, sorry, that's a multiply. I know some of these are kind of hard to see. It'll be easier when you can look it up on your own, yeah. So even maybe what I'll show there, instead of having that dot, I'm just going to, whoopsie, that's not what I wanted to do.
Are we allowed to print out that paper and submit it that way?
Yep, you are. I just need to, I think I still need to get it into Canvas. But for right now, if you just want to work it on paper to the side, and then if you want to, and you can even, actually this one's a PDF, so you're not going to really be able to write on it. and I don't have it in a document format. Some of you that have like more than just the like Adobe Reader, you would be able to get in and you could, you know, type things in here and stuff, but you'd have to have like the full access to Adobe to do that. But that's why I said you can just work it out on another sheet of paper too. I'm perfectly fine with that. Okay. I want to make it as easy as possible for you. Just write it like this so you can see those are the two things that you're multiplying together. But notice these aren't what a binomial times another binomial, right? So just like so you could write it out with the things that are okay, so I'm just showing that, and then you'd want to simplify those more on there. Okay, we're just about out of time here, so I just wanted to see, are there any questions that came up on this that you want to ask before we go? All right, so this is number one, what I wrote there. That's just a start to it. That's not the answer, right? So you have to keep going further on that. But I just want to make sure that you're seeing that's not the same thing as like what we have down here on number 7, where you're doing a binomial times another binomial, right? You'd have to write that out. This is just combining, you know, like multiplying the things together that are the same, like we did on the properties of exponents. Right, so just noticing the differences there is super important. Okay, well, we're going to stop there then today. Like I said, I'm going to put this, and I'll send you guys an email out today, just kind of, you know, going over things, what's due when, and where to find things, just some extra, you know, helps and stuff. I know it's different meeting this way and stuff, and I want to try and help you as much as I possibly can. Please reach out to me when you have questions, though, so I can help you with that. And remember to come to those online office hours tonight, okay? I'd love to see you there. I'd love to help you with that, okay? All right, if you have any questions, you can stay on while everybody's getting off, but otherwise I will talk to you guys later. Have a great day.